So hello everyone, today we will be discussing a very important concept in data science, which is bias variance trade-off. So let's get started. What is bias? What is a variance? And what is bias variance trade-off? And what is its significance? Means how we can interpret what we can interpret from it. So in this example, we will be using linear regression, which is a regression algorithm, and here is one diagram with three graphs, and I have listed some of the properties of these graphs down here. You can read that. So first one is our linear regression model, which has degree of polynomial 1, and these red points are our training data points. So as you can see, uh, our model is not uh, satisfying all the points or some of the points for that is for prediction. So we can say it is underfitting and has high bias. We will discuss later what is bias variance. And this blue line is our model prediction line. Second one is our degree of polynomial model, which is quadratic regression. Here you can see it fitting on some of the points and not fitting on some of the points. So we can say it is just right or best fit for our data. And third one is our more than 2 degree of polynomial model, which is multinomial regression model. So we can see that it is trying to catch all the training points. So we can say it is performing very well on the training data set, but it will not perform good on validation data set, as a validation data set will be out of these points, like this black one. So it will not able to predict on these black points. So yeah, we can say that it is overfitting and has high variance. Next one, what is the meaning of high bias? High bias means our model is simple for our data. As you can see here, our model is not able to catch all the or some of the training points. So we can say it is simple for our training data. And uh, as it is simple, we can say it has high bias. These two things are interrelated. High bias, simple model. Same for the high variance, complex model. Next thing, bias variance trade-off. Here on y-axis we have drawn error, on x-axis we have drawn model complexity. And as we go further on x-axis, our model will be more like this third one, multinomial regression. And near on near zero, our model will be simple like this first one, linear regression. And here on the middle point, our model will be just right or best fit, like quadratic equation. So this is the perfect point for deciding model. Means we should decide model which has good prediction ability on our data. So it must not be so complex, not so simple for our data. So it must be intermediate one, like here this one point on trade-off. Next will be uh, bias variance and model complexity simplicity relation. As we have seen earlier, High bias means simple model and high variance means complex model. So here is one like a pendulum. On one end of pendulum there is simplicity and on other end there is complexity. So our main goal is to achieve equilibrium like this second one diagram. So model should not be simple or too complex for our data. Here are three graphs, same as previously seen graphs with some good visual representation. You can, and this is another diagram which is representing same. So if our model has low variance, low bias, then it will good fit for our data. This red one point is good good fit point, we can say. For now, say it like that good fit. And same for other points. If it has high bias, our model will be very simple for data, so it will not fit the data. As you can see, our data is not near to this red. And if it has high variance, it will fit training data but not validation data. As you can see, some of the points are nearer to this red spot, but they are training points. So these are some key takeaway points. You can read them, and we will discuss next our code implementation for that. So for this code implementation, you will need a YAML extend library. You can install it like this exclamation mark pip install YAML extend. So these are required libraries. We will need these libraries while performing this task. Pandas is for data handling. It means file handling. Pandas can handle different files like CSV, Excel, and sklearn is for is linear regression. We are importing linear regression. There are different machine learning models in sklearn, and ML extend for is for finding bias and variance value at the last. So here we will import our housing.csv dataset using pandas.csv, and we will print some of the values using first 5 values using dataframe.head function. Next we will separate our dataset into input and output values. Input values is what we will give input to our model, and output values are what our model need to predict. We will give some set of the input output values. From that model will find some relation, and then we will predict our model on new data points. Here I have given one example for understanding purpose, you can see it. And the same here I have shown some is of slicing operation. Slicing operation of Python list. You can search it on Google, or it is simple to very simple to understand. Just experiment with it. Next we will divide our data in train, test. So for model, training data will be used for training purpose in model, and testing will be for testing purpose. Then we will create an instance of linear regression algorithm, and then we will fit it on training data, and then we will predict it on testing data. So y test is our original testing points, and these are predicted one. From that we will find model MAC, error, bias and variance, and here you can see MAC, bias